Hello students, welcome to the second lecture of the lesson number 7. In previous lecture, we have learned about the types of numbers, the different types of numbers, and we also learned how to find out rational numbers between two rational numbers. Right? Today, we are going to solve NCERT exercise 1.1. Yes, some questions from NCERT exercise 1.1. These questions are very easy and statement based, means we don't need to solve anything in such questions. We just have to write the answer into the statement, just like we have done or we are doing in science or any another theoretical subject. Okay, so what are these questions? Let's have a look. See us. In NCERT exercise 1.1, question number 1, they asked us, is 0 a rational number? Can you write A in the form of P upon Q, where P and Q are integers and Q is not equals to 0? Tell me one thing. What is the denominator of the number whose any denominator is not given? What is the number in the denominator of numbers whose denominator is not given? ऐसा वैल्यू बताइए, ऐसा कौन सा नंबर होता है जो किसी भी नंबर के डिनोमिनेटर में दिया है? यानी सपोज 5 हो गया, 6 हो गया, 7 हो गया, कोई भी नंबर हो, इन सब का डिनोमिनेटर नहीं दिया है तो इनके डिनोमिनेटर में कौन सी वैल्यू रहेगी? 1. So here also 0 is a rational number because 0 don't have a denominator, means it has a denominator with the number 1. Since there is a 1 in the denominator, we don't need to write a 1. We don't need to represent a number into a fraction because it is understood that if there is no denominator given to any number, it means there is a denominator of 1. So yes, 0 is a rational number. We will write yes, 0 is a rational number. 0 is a rational number. It can be written as 0 upon 1, means P upon Q. It can be written as 0 upon 1, where 0 is integer and 1 is also integer, and Q is not equal to 0, means denominator is not equal to 0. So the answer is yes, 0 is the rational number and it can be written as 0 1. And here the answer of this question is okay guys. Now question number 2. State whether the following true or false. This question is asked as a question number 4 into the exercise, but as we are not solving question number 2 and 3 because same kind of questions we have already learned into the previous lecture, so that questions are homework. So we will jump to the question number 4 directly. State whether the following are true or false. The given question are true statements are true or false, and give a reason. And we have to give a reason. If they are true, then also we have to give reason, and if they are false, then also we have to give the reason why they are true or why they are false. Okay. So the first statement is every natural number is a whole number. Every natural number is a whole number. Whether it is true or false. Yes, natural number starts from 1, 2, 3, 4, 5. And whole number starts from 0, 1, 2, 3, 4, 5. Means natural number starts from 1, 0, 1, whole number starts from 0. It means all natural numbers are included into whole numbers. Therefore, we can say that every natural number is a whole number. So the given statement is true. So we will write yes or we will write true. Every natural number is whole number. How? What is the reason behind that? Natural number starts from 1 and whole number starts from 0. So all the natural numbers are included into one number. So the given statement is true. Right? Now, the second one. Every integer is a whole number. Every integer is a whole number. See, integer includes all positive number, negative number and 0. Whole number includes 0, 1, 2, 3, so on. Means 0 and positive numbers. Integer includes negative numbers also, but whole numbers are not included, not includes negative number. So integers, every integer can be a whole number. Therefore, given statement is false. Every integer is not a whole number. Reason behind that is integer are negative number and whole number includes positive number only. Therefore, the given statement is false. Okay? Next, third one. Every rational number is a whole number. Every rational number is a whole number. Now, see, what is the definition of rational number? Definition of rational number is a number which can be written in the form of P upon Q, where Q is not equals to 0, but P and Q are integers. If the components of rational number are integers, means numerator and denominator of a rational number can be an integer, then how it can be included into whole number? So the given statement is false. Every rational number can be a whole number because numerator and denominator, you have to write full form of this, numerator and denominator of rational number are integers which are not whole numbers. Therefore, the given statement is false. Okay guys, this is how we have to write such kind of statement. Such questions are asked into the section 1 of your paper, which is for 1 marks only. So, this kind of objectives may be asked into your exam for 1 marks. Okay guys, now I request you all to pause this video and note down this all statements into your copy and then continue the video again. Now students, we will learn how to represent irrational numbers. How to represent irrational numbers on number line. Right? Irrational number on number lines. Yes, we have learned how to represent rational number on number lines in standard 8. But how to represent irrational numbers on number line? Let's have a look. See guys, what do you mean by irrational numbers? Irrational numbers are the numbers which cannot be written in the form of P upon Q. Which cannot be written in the form of P upon Q, where P and Q are integers and Q is not equals to 0. We have learned the meaning of irrational numbers. What do you mean by irrational numbers? Irrational numbers are numbers whose decimal expansion is non-terminating, non-recurring. Right? Similarly, square root of non-perfect square number are irrational numbers, right? Square root of non-perfect square number are irrational numbers. Non-perfect square number means what? Numbers which are not the square of any other number. Numbers which are not square of any other numbers. Such numbers are known as irrational numbers. Just like I am telling you, square root of 5, square root of 3, square root of 7. 5 is not the square of any number, so it is known as irrational number. Root 3 is not the square of any number, it is an irrational number. Root 7 is not a square root of any number, so it is called irrational. Right? Now we have to represent such root values. That is, we will say irrational numbers on the number line. So how to represent it? Let's have a look over here. Okay? See guys. Firstly, we will represent root 3, root 2 on number line. Root 2 on number line. And in second example, we will learn represent root 6 on number line. Okay guys? Now see how to represent such numbers on number line. This is a number line as we have done before also. I am starting it from 0 and will continue so on. So 0. There is no such rule to have a difference of 1 centimeter only while representing the root values on a number. Okay, we can take a difference of 2 centimeters also. Okay, so to represent such root values, we will take a difference of 2 centimeters between each point. Difference of 2 centimeters. So 0 after 2 centimeters, I will consider the point number 1. And then after, I will consider the point number 2. Then after, I will consider point number 3. Then after 4 centimeters, 4, 5, 6, 7 and so on. There is no necessary to represent that numbers. We can represent 2 to 3 numbers also. Okay. Now we have 0, 1, 2, 3, 4, 5, 6, 7. Difference between two consecutive points is 2 centimeters. Okay. Now, see guys. I can write 1 as a square root of 1. Because square root of 1 is 1. This is the number 2. Number 2 can be written as square root of 4. Number 3 can be written as square root of 9. Number 4 can be written as square root of 16. 5 can be written as square root of 25. 6 can be written as square root of 36. 7 can be written as square root of 49. Right? It means what? If number 1 is representing root 1 and number 2 is representing root 4, means value that is number root 2 and root 3 lies between root 1 and root 4. Value of the number of root 2 and root 3. Number of root 2 and root 3 lies between 1 and 2. Root values of 5, root 5, root 6, root 7, root 8 lies between root 4 and root 9. That is the point 2 and 3. So, if we have to represent root 2 on a number line. So, the number next to root 1 will be root 2. And that root 2 will lie between 1 and 2. That root 2 will lie between 1 and 2. That is root 1 and root 4. So how to find out? Let's have a look. See guys. From value of root 1, that is the number 1, draw a line of 2 centimeters. How many? 2 centimeters. Okay? Join the end of this line with the point 0. Join the end of this line with point 0. Okay? In divider in which there is one pointed nickel and another side there is a holder to put a pencil. Okay? Take a distance of 0 and this point, the triangle which is following. Right? So take the distance of hypotenuse of this triangle. It means the distance between this 0 and tip of this line. and may mark an arc on a number line, just like this I have drawn. Okay, take a distance between this point A and 0 and mark R on this number line passing through point A and which intersects the number line. Okay, let give this point as a name B, and this point will be known as root 2. This point will be known as root 2. Okay guys, this is how we will represent root 2 on this number line. Okay, now if we have to represent root 3 will be after root 2. Root 3 will be after will come after root 2. So what will we do? Let's draw again the line of 2 centimeter over here also. I am erasing the name of this one. Okay, the height of the same height which is of the point 1. Now join this line also with 0. Join this line also with 0. So I have joined this line also with 0. Now let's give this point name C. Now take a distance in your divider from 0 to C and draw a graph. Draw a arc between which carries the distance of 0 and C. So this graph will come after the point of root 2. After the point of root 2, and this point will be known as root 3. This point will be known as point root 3. Okay. Now after root 3 there is a value of root 4. So root 4 we have already represented as a point number 2. So this is how we will represent such values, such irrational numbers on the number line. Okay guys, I hope you understand the construction of these root values. Okay. Now another example, represent root 6 on a number line. Okay. Again, I start from 0, after 2 centimeter 1, after 2 centimeter 2, after 2 centimeter 3, after 2 centimeter 4, after 2 centimeter 5. Right? Since 1 is known as root 1, 2 is known as root 4, and 3 is known as root 9. So root 6 will lie between root 4 and root 9. Root 6 will lie between root 4 and root 9. So how to represent root 6 between root 4 and root 9? See. For representing root 6, first we have to represent root 5, because from the point of root 5 we can represent root 6. Okay, so let's represent root 5 first. Draw a line of 2 centimeter on value of on the point of 2, which is root 4. Join this end with 0. Okay, now take a distance between 0 and this A in the divider of your handset. Now draw a graph from this by taking a 0 and A as a distance, and this point will be root 5. Right? Now we have the point of root 5. We have represented root 5. Next point after root 5 is root 6, and this is what we have to represent. So again, from the point of root 5, draw a line of 2 centimeter again. Draw. Now let this point known as B. Take a distance. Join this B with O. Join this B with O. Join and take a distance of OB into your divider. Make an arc of it, and this arc will intersect the number line also. And that the point at which this arc will intersect the number line, that point will be root 6. That point will be root 6. And this is how we will represent root 6 on the number line. Okay guys? So this is the method to represent the irrational values, that is irrational numbers on the number line. Okay guys, I hope you understand this topic. If you didn't understand, if you don't understand, watch this video again. Okay? Now I request you all to pause the video and note down this construction from the book.